Hi everyone, welcome to my poster. My name is Aldo and I'm going to present some results of my poster, Theoretical Study of the Optical Properties of Copolymers of Porphyrins and Polyethylene Glycol by DFT. Porphyrins are compounds frequently found in nature in some biological processes. For example, chlorophyll is a compound involved in photosynthesis and is the substance that gives the green color to the leaves. Here I show the representation of the structure of chlorophyll. On the other hand, porphyrins and derivatives have been studied as compounds with potential application in solar cells because of their optical properties. As a consequence of these properties, the porphyrins have led to use in photodynamic therapy. Porphyrins have the ability to coordinate a large number of metals. These new compounds are called metalloporphyrins. The coordination of a metal to the roles of the microcycle modify the optical properties of the porphyrins, such as their absorption and emission spectra. In this slide I show how the emission spectra change when zinc is coordinated to the porphyrin. Two bands are shown in this spectrum, but one found a higher energy in a particular characteristic band, and therefore porphyrins have potential use as metal sensor. Recently, a copolymer from tetraphenylporphyrin and polyethylene glycol was synthesized by frontal polymerization. The optical properties of these materials were typical of the porphyrin unit with a source band at 480 nanometers and a fluorescence emission band at 653 nanometers. On the other hand, this hydrogel polymer, tetraphenylporphyrin and polyethylene glycol, was proved as a fluorescence sensor of metals as copper, zinc, nickel, and cadmium, with changes in the intensity of emission bands about 650 nanometers. However, some technical inconveniences have not allowed the study of their UV spectra. In addition, in order to undertake the synthesis of a sensor based on porphyrins, we need to understand the electronic properties of the compounds. The density functional theory is one of the most common methods to study the molecular configuration of metalloporphyrin, and it has become the preferred method to calculation a variety of molecular properties and been successfully applied to understand the electronic structure of molecular systems. Therefore, we simulate the absorption spectra by time-dependent DFT of the porphyrin complexes, and we predicted the geometry and state to understand the role of the polyethylene glycol chain in the hydrogel when the porphyrin coordinate a metal as copper, zinc, nickel, or cadmium. Here are the results. The compound derivative from tetraphenylporphyrin polyethylene glycol was tested with aqueous solution of zinc, copper, nickel, and cadmium salts at room temperature. UV spectra of PET and the complexes with the porphyrin with zinc, copper, nickel, and cadmium are shown in this slide. The solar band is found in the range between 401 nanometers and 411 nanometers. The orbitals involved in this transition show a solid band is constituted mainly by transition HOMO less 1, HOMO 0, LUMO 0, and LUMO plus 1, although in copper show an important contribution from HOMO less 2, this part in red, and LUMO 14. HOMO less 2 has an important contribution in copper complex 68 and 63% respectively. In this slide is represented the structure of the free-base porphyrin. The torsion angles are related to distortion of different parts of the porphyrin. In green color are the torsion angles related distortion of the roll ring, while in red color torsion angles to deviation of the roll of the plane of the porphyrin. The more drastic changes are found in the excited state or nickel and cadmium compounds against the ground state. Therefore, they are the most distorted compounds. Finally, in blue color are the angles which describe the spatial orientation of the phenyl rings relative to the porphyrin core. The smallest deviation from zero, the more planar the molecule. Here I show the geometries of cadmium and nickel metal porphyrins in ground state and excited state. We can observe that when excited in solar band, the geometry that more distorted is that of the porphyrin with nickel, and it involves both the microcycle and polyethylene glycol chain. Therefore, this chain gives flexibility properties to the polymer. Finally, we have some conclusion. UV spectral of porphyrin and some complexes were studied by time-dependent DFT. They show that the solar band is constituted mainly by transition HOMO-LUMO in porphyrin base free base and zinc, nickel, and cadmium compounds. However, another contribution can be important as HOMO less 2 and LUMO plus 14 orbitals in the copper complex. In addition, the excited states geometry show that excitation of solar band geometric core can be modified and promote the rotation of the meso subsequence. Finally, polyethylene glycol chains provide flexibility to the composite chain porphyrin. The clearest examples are those observed in nickel and cadmium complexes. That's all. Thank you for watching my presentation. I hope you see my poster. See you later. Thank you.